Every time someone clicks a link, a request travels as a pulse of light through miles of physical silica glass to reach your server. If you look at most hosting company comparisons, the advice seems obvious. Pick a data center in your local city, and your website will load instantly. But that advice ignores a hard mathematical limit. Light traveling through a vacuum is fast, but it moves about 30% slower when it's bouncing through the core of a fiber optic cable. The physics give us a fixed rate. A signal covers about 200 kilometers every millisecond. That means 1,000 kilometers of distance costs roughly 10 milliseconds of travel time. And we have to measure that as round trip time because the browser has to open a connection, negotiate TLS security, ask for the document, and ask for all the images. A single page load requires multiple round trips. We see operators constantly paying premiums to move their servers closer to their audience. Meanwhile, they completely ignore the software bottlenecks sitting right inside the server itself. Trying to beat the speed of light by changing geography is an expensive distraction when you haven't actually fixed the code making your visitors wait. The latency control ladder breaks down the 5 phases between a click and a painted page, ranked by your control to fix them. Rung 1 is server response time. Adding a server-level cache drops an uncached 800 millisecond delay into the low tens. Rungs 2 and 3 are connection setup and DNS. Rung 4 is physical distance. Moving a server across the country saves 30 milliseconds. Meanwhile, turning on a cache saves hundreds of milliseconds. If your server struggles for nearly a second to assemble an uncached document, that 30 millisecond geography gain is completely invisible to your user. Physical distance is a tiebreaker. It only matters once you've successfully cleared the first 3 rungs and are chasing your last few milliseconds. Buying a server based on the city map before auditing the internal software stack is a massive misallocation of your hosting budget. Content delivery networks are heavily marketed as the total solution to this distance problem. For static files, a CDN caches copies at edge nodes right next to the user, erasing the distance penalty. But when a user starts a checkout, that request bypasses the edge nodes and travels the full distance back to the origin server every single time. This creates a blind spot for WooCommerce operators. The exact pages that generate your revenue are the ones making full round trips across the country, and the path they take isn't a straight line. Network topology forces your data into navigating a maze of internet exchanges and router handoffs. 2 servers can be the exact same distance from a user on a map, but deliver completely different latency. It all depends on where the data center's network physically connects to upstream carriers. Picking a host just by looking at a city name tells you almost nothing. The actual speed is decided by which carriers the network uses and where those handoffs occur. If you run a static blog, a CDN protects you. But if you run an interactive store or an application, you have to obsess over your origin location and the network path. This scorecard breaks down exactly where you should focus your optimization efforts based on your specific workload. If you operate a standard blog or a brochure site, stop worrying about the data center zip code. Focus entirely on configuring a robust server-level cache. If you operate WooCommerce or SaaS applications, assume the distance penalty hits every single page that converts. You need to prioritize the physical location of your origin hardware. The rule is straightforward. Maximize the latency factors you can eliminate with software before you try to negotiate with the speed of light. Test an uncached page right now. If your time to first byte is sitting at several hundred milliseconds, your bottleneck is in the software stack, not on the map. Server geography enforces a strict physical limit on your website. Just make sure you fix your code before you treat distance as your primary problem.